All right, guys, today we're going to write polynomial functions and models from some information they give us. So kind of backwards from what we did yesterday, but that's okay. Here we go. First one says write a cubic function whose graph is shown. And one thing I know from looking at that graph is I know what the x-intercepts are, which is there's one there, and there's one there. And remember, those are the factors. So what I'm going to do is I'm going to write it as factors. I'm going to put f of x. I'm going to put the a in the front because that's going to determine, how if it's positive or negative, how the ends go, and also kind of how fat or skinny it is. And we'll talk about that tomorrow. -4 is the first one. I always put the opposite in the parentheses. 1 is the next one, and 3 is the last factor. So I know that much just looking at the zeros or the x-intercepts. Now, the other thing I have is I have this point down here. And again, the reason that point is on that graph is because it works in the equation. It works. It's a solution. So what I'm going to do is I'm going to put a -6 in for the y, and everywhere there's an x, I'm going to put a 0. So I get 0 plus 4, 0 minus 1, 0 minus 3. So I get a, and over here, when I multiply that out, that's 4 times -1 times -3, which would be 12. A, if I divide by 12, I get a is -6/12, which is really -1/2. So to write my function, I'm just going to put that a, -1/2, right there. So my answer is going to be f of x equals -1/2, x plus 4, x minus 1, x minus 3. And again, the first 3 factors come from the zeros, then you got to plug in the other point to find your a value, to tell you what the ends do, what the end behavior is, and also kind of the width of the graph. All right, finite differences. This is going to be a big deal the rest of this video. Finite differences are differences between your y values. So what I've done here is I put a function down here where it's f of x equals some function, and f of 1 is what the red is what it equals. F of 1 is 1, f of 2 is 4, f of 3 is 9, f of 4 is 16. Now watch what happens here. If I find the difference in those y values, that difference is 3, that difference is 5, that difference is 7, which is okay. But if I do that again, if I find the differences again, the difference there is 2, the difference there is 2, that's where they're finite differences. The finite differences are the same, but I have to go 2 levels. And that's a big deal. I had to go what's called second order to get there, to find the finite differences. When the x values are equally spaced, the differences of consecutive y values are called finite differences. So my x values are equally spaced because my x's were 1, 2, 3, and 4. The numbers down here are my y values, or my f of x. Okay, a couple properties of finite differences. Number 1, if a polynomial function has degree n, the nth order of differences should be equally spaced, and as long as x values are non-zero and constant. Number 2, conversely, the opposite is true also. If the nth order are equally spaced and are non-zero and constant, then the data can be represented by a polynomial function of degree, and so the degree tells you how far you have to go before they're equally spaced. Let me show an example down here on the bottom of the screen. Let me move this up a little bit. All right, so this is an n squared problem. So what I'm expecting is by the time I do the differences twice, the differences are going to be the same. So I'm going to do the differences first. Like that's the difference of 2, 3, 4, 5, 6. So those differences are all different. But if I do differences again, the differences are all 1. So all the differences are the same. And it took me I had to do it twice to get there because it was degree 2. If it's degree 3, it would take me 3 times to get there. And that's a big deal for what we're about to do. So whatever your degree is, when you do finite differences that many times, you will get the same difference. All right, last thing here. Use finite differences to find a polynomial function that fits the data in the table. So what I did is I took the table. This is my x's. Notice they're the same distance apart, 1, 2, 3, 4, 5, 6. These are my f of x's. So what I did is I just did finite differences. I found the differences the first time, and I got these numbers right here. I got 9, 7, -1, -15, -35. Found differences again, got 2, -8, -14, -10. Found differences again, got -6, -6, -6. So the differences are all the same, which means because it took me 3 times to do that, that means my function is cubic. It's a cubic function, means degree 3. So a degree 3 function looks like this, looks like ax cubed plus bx squared plus cx plus d equals y. All right, so your job is to write the function. You got to find a, b, c, and d. So what I did is I took each point of the first 4. I took this one, and I plugged the 1 in for the x's and the 6 in for the y. That's where that came from. I took the second point, the 215, plugged it in, did the same thing. Took the third point, plugged it in. Took the fourth point, plugged it in. And the reason I did 4 is because I have 4 variables up here. However many variables you have in your equations, how many points you need to use. That's why I use 4 of them. All right, so what I did next is I multiplied them all out. That's when I came down to here. I basically did the 1 cubed, 1 squared, 2 cubed, 2 squared, 3 cubed, 3 squared, all that to get all these equations here. Once I have that, the only way I know how to solve that right now is using an inverse matrix. So I'd use the inverse matrices and to try to find my A and my B and my C and my D. So I'm going to stop right there today, and we'll pick up right here tomorrow because I want to show you on the calculator a great way to go through here and get that. But I do need you to understand the main thing from this slide, the last 2 slides is, however far I did differences 3 times, so I knew it was cubic, and that's so important to know it's cubic. If it had taken me 4 times, it'd been quartic, where the degree would be 4. 2 times, the degree would be 2. All right, I'm gonna let you go. I'll see you tomorrow. We'll work on these, and see you then.